One is when there's just a log on one side versus when there's a log on both sides. So 1 through 6, there's only one log on the left. Log on the left, log on the left, log on the left. When you get down to 5, the logs, there's 2 of them, but they're still both on the left-hand side, and same with number 6. So when the log is just on one side, you get the log pretty much all by itself, which it is. This is just log base 4 of whatever. And you translate it into an exponential function. So you take your base of 4, just using your translation, base of 4, raised to the other side, 2, equals whatever you're taking the log of, and then you just solve. So subtract 3 from both sides, and x equals 16. That one, or x equals 13. That one was easier because the log was already isolated. Number 2 is going to be the same thing. So jump to 3. In 3, the log is not isolated yet. You've got the log of 2x, but there's something in front of it that we need to get rid of first. So we get rid of the 3 by doing what? Division. You get natural log of 2x equals 4. And then, so if we're translating out of this, what's technically the base of the natural log? Of the natural log, e. So that's e to the 4th power equals 2x. How many of you last year would have, if you had an ln to get rid of it, you just would have raised e to both sides? That look familiar to anybody? And your e to the ln would cancel, and you'd get 2x equals e to the 4th. It's obviously the same thing. And then just divide by 2. And x equals e to the 4th over 2. Correct. Like, what were you thinking? Maybe do 4 divided by 2? Yeah, you can. That's that. 4 is very much the same. 5 is where it gets a little bit different, but you still have logs just on one side. The problem is we can't translate until it's a single log. So this is where condensing is used. So when you have 2 logs and you're adding them together, what operation do you do to condense them into one log? Multiplication. So that's going to be x squared minus 7x. Does everybody see that? When I multiply x times x minus 7 equals 3. And now that it's just a single log, nothing out in front of it, nothing after it, we can just translate. So Carolina, what would this translate to? When I so like up here, when I translated this one, I took the base, which was 4, raised to the other side, equals whatever's in the middle. Yep. Yep. Good. And this is the first one where it actually became what type of equation to solve? Quadratic. So I have to get it equal to 0. So subtract the 8 over. Solve the quadratic by factoring if you can, which you can. Yep.
Say like you got one of your things to equal 7, you canceled them?
Yeah. What is that, Laura? What does that factor into? X minus 8, x plus 1. So I get x equals 8 and x equals negative 1. And you want to check answers always for extraneous. So if you plug back in an 8, is there going to be a problem? I'd be taking the log of 8, that's okay. And I'd be taking the log of 1, which is not a problem. If I plug in negative 1, I'd be taking the log of negative 1. Problem. Yes? You can only take the logs of positive numbers. So you have to reject that. if you want to write that, can only take log. Okay, so those are all versions of logs just being on one side. You condense if you need to, and then translate. Versus when you jump down to the next section, you have logs on both sides, which may be easier. You still have to condense. So subtraction turns into what? Division. So that'll condense into the natural log of x plus 2 over 4x plus 3. And then once you have the like a single log on the left and a single log on the right, they'll just cancel. The logs will just cancel, and that's the equation we're solving. And how would you solve that? Cross multiply, good, Brock. So cross multiply, you get x squared plus 2x and 4x plus 3. So subtract your 4x over, subtract your 3 over. Because it's another quadratic. So when we get our answers here, we're definitely going to have to check them. This factors into x minus 3x plus 1. And I get x equals 3 and negative 1 are either of those problems. Negative 1, because when I plug it in here, I get the log of a negative and there. So we would reject that one. And that's our answer. Good? Do you foresee any issues with 8? The only thing I can maybe see is once you cancel your logs. Okay, yeah, exactly. It's not a fraction equals a fraction anymore, but you would just put that over 1 and still cross multiply. Good? That's it, because then we get into graphing and we're not graphing. Let me think. I'm going to have you do 1s, 5s, and 9s.
You just looked at the clock and smiled, didn't you?
Because I smiled because I saw you see me look at the clock as I was deciding. So 1s, 5s, and 9s. No, because we're not going to do that. Just correct.
Oh, what is it? 1, 5, and 9.